Welcome. This is going to go over the Module 1 Review Packet Solutions. This is for honors. Part 1. It says to write a formula to represent an arithmetic sequence in which the first term is 8 and the second term is 24. So we start here by having written out the first two terms, which is the information given. 8, 24 gives you a visual representation of what the question is asking for. Next, we compute the common difference. The common difference is going to be the second term minus the first term, so it's 24 minus 8. So you would say that the common difference here is 16. We use the letter D for the common difference. Computed next here is the zero term. The zero term is defined as the first term minus the common difference. Because to get to the next term, to get to like the second term, you would do the first term plus the common difference. But to get to the zero term, you're going backwards. It's the first term minus the common difference. So in this case, it would be 8 minus 16 because the first term was 8 minus 16 because that was the common difference. And you get f of 0 is equal to negative 8. The reason why we need the common difference and the zero term is because you could write the linear equation in function notation would be f of x is equal to mx plus f of 0. Please understand that the m here stands for slope, which is similar to the common difference. So you would say it is 16x minus 8 because that is the first term. So here you go. This would be how the arithmetic sequence would look like in the function notation. Okay. You could also write it in the using the a of n, which is in the sequence notation, which uses the f of 1 and the common difference. You're most likely to see this when it talks about sequences. F of 1 here was given as 8. Just to let you see, this was your f of 1. Okay, so you would get a of n is equal to 8 because that is your f of 1 plus f parentheses n minus 1 times your common difference, which is of 16. Okay, please understand that nothing happens here. Nothing happens here. Okay, it's just rewritten again. This is equivalent to writing this, the x term. Okay, good. All right, next one. Write a formula to represent the arithmetic sequence in which the first term is 8 and the third term is 24. Okay, so I can write out the sequence. The first term is 8. The second term is 8 plus the common difference. The third term would be 8 common difference. Ooh, this is off. Give me a second here. This would be a 2. This would be a D. 2D equals to 24. I think that's where I did it wrong. Yes. So here would be 8. The second term would be 8 plus D. The third term would be 8 plus 2D equals to 24. Okay. And then what I wrote out here would be how I would have to solve for the common difference. So let me just write it out here. 8 plus 2D is equal to 24. Subtract 8. Subtract 8. You get the common difference is equal to, give me a second, 16. Okay, 8 divide by 2, divide by 2, you get the common difference here is 8. Okay, what you have to compute now here is going to be the zero term, And we know that the 0 term is going to be given as the first term minus the common difference. So in our case, it would have been 8 minus 8, okay, which is going to be equal to 0. The common 0 term here is 0. What needs to happen next is you can write the function as f of x of f of, it should be mx plus f of 0, which is going to be 8x plus f of 0 here would be 0. Or you could write it in sequence notation, which is an is equal to f of 1 plus and minus 1. Is it at? Yep, it's times the common difference. The first term here would be 8, so it would be 8 plus n minus 1, and the common difference here would be 8, so that would be 8. Okay, so that's how that one would look like. Okay, alright, number 3, write a formula to represent an arithmetic sequence in which the first term is 8 and the fourth term is 23. So the first term here is 8, the second term here is 8 plus d, the third term would be 8 plus 2d, and the fourth term would be 8 plus 3d, which is equal to 23. Let me help you out by giving you, by writing it out. This is the first term, this is the second term, this is the third term, and this is the fourth term. Okay? So here we could get the common difference. Right. This is the equation. So 8 plus 3d is equal to 23. Subtract 8 to both sides, you get 15 over on the right hand side. Divide by 3 to both sides, you get d equals to 5. Okay. Once that, you would now find the 0 term. The 0 term is defined by the first term minus the common difference. So it would be 8 minus 5, which is equaling to 3. So you would say that the f of 0 is equal to 3. Next, you would write the formula out for the arithmetic sequence. It would be f of x is equal to mx plus the f of 0, which is the first 0 term. M here, which is the slope, which is similar to the common difference, which is 5. So it just becomes f of x equals to 5x minus 3. The 5 comes here for the m, which is slope. Is similar to the common difference, so that's where that 5 comes from, and the 0 term is given right there, comes from that calculation as well, which is 3. You said, ooh, something's wrong. This should be an add. Okay, this should be an add, because again, it's not minus, it's add the 0 term, and the 0 term was a 3, so it's add 3. So that was the mistake there. Hopefully I didn't make the mistake here. Yep, this was correct. This is in sequence notation. F of n is equal to f of 1 plus f parentheses n minus 1 times the common difference. F of 1 here, which is 8, and the common difference here, which is 5. Okay, there you go. Part 2. Determine if the following is an arithmetic, geometric, or neither. The first one, there's a couple of things that you need to understand. For the arithmetic, there's going to be a common difference. For geometric, there's going to be a common ratio. And for neither, there is not a d or a common ratio. There's no common difference or a common ratio. All right, so the first one, you can use the formula to test it out. You should have gotten a common ratio of 12. If you would like to see the work, it would be 4 minus 4 divided by 8, which becomes 1/2, or you can do 2 over 4, which is also 1/2. Okay, the fact that there is a common ratio, you would say it is geometric. Second, And the common difference is negative 4. Let me show you the work here. It could be 4 minus 8, which is equal to negative 4. Or you could do 0 minus 4, which is equal to negative 4. Okay, you could do second minus first or third minus second. Okay. The fact that there's a common difference, you can then say it is arithmetic. Next, 1, 1, 2, 3, 5, 8. This is neither. This is actually a famous sequence. It's called the Fibonacci sequence. Okay. I think the term is the next term is a summation of the previous two terms. Okay, but it's neither. It's neither arithmetic or geometric. Okay, so the next one, we get r equals to 1/2. If you would like to see that, again, it's the same calculation as a. It would be the second term, which is 1/4 divided by 1/2. Okay, that gets you r equals to 1/2. You would say that is geometric. Next, Johnny starts off with a full battery life on his iPhone. Every hour he uses his phone, his battery life decreased by 15%. The fact that it's decreased by 50%, you should already know. It is a common ratio. In this case, fully, it's at 1 minus 1.15 because 1.15 is just the decimal version of 15%. Okay? You get r equals to 0.85. Good, so you would say that this is geometric because there is a common ratio and is 0.85. Next one, Ryan has to tab his book for English class. He can tab 10 pages each night when he reads. So in this case, the common difference would be 10 because you're adding 10 pages every single day. The fact that there is a common difference, you would say it is now arithmetic. Part 3. Which of the following function gives the number of shaded squares? So what we need to do is test out all the different solutions here. So what I did first of all is I put it in a chart format. The 0, we didn't know what shade it's for 0. 1, we know that the shade is 8. 2, we know the shade is 12. 3, we know the shade is 16. And 4, we know the shade is 20. There's multiple ways of doing this, but it looks like there is a common ratio of +4 here. There is a. So here you could plug it into your arithmetic or geometric, but the fact that it is a common difference of 4, you could try to plug into your recursive or explicit. It doesn't appear though. Okay? So we gotta test out each value by itself. Okay? So the first one is S of n is equal to n plus 2. So here we know that for the first term, for n equals to 1, the answer or the output or the S of n has to be 8. This is what this column says. That's what this says in English. So the n becomes 1, so the n becomes 1. This is what happens when you start plugging values in to check. You've done this in your ready, set, goes, okay? So your S of 1 equals to 3. Does this work? Is your S of 1 equal to 3? No, your S of 1 needs to be 8 when this is true. So it would say A does not work because your output was 3. The output was supposed to be 8 based on the chart. So A does not work. Now let's check the second one. Remember, if we plug in n equals to 1, the output has to be 8 because that is what the chart says. So I'll plug in the value of 1. So the n here becomes 1. 8 times 2 to the power 1 is 16 minus 1 is 15. Does that work? No, B does not work. Next, you want to test out the third one. So again, let n equals to 1, then S of n has to be equal to 8 based on the chart. So plug in 1 for n. This becomes 0, so this should become 8 of n is equaling to 8. Wow, look, it works. Okay. Once you test out one, always test out the second one. So we know C does work, but let's check it one more time. Okay. Here's the sequence or the function for if n is equal to 2, the answer has to be equal to 12. Let's see if that works. Okay, plug 2 in here for n. 8 plus 2 times 2 minus 1, which is 1. So it's 8 plus 2, which is equaling to 10. So once we check it again, but with the second term, it doesn't equal to 12. So we would say that it doesn't work. So this is why we check multiple terms. Even though it might work for one term, it has to work for all the terms. Okay. So I normally check the first one, then the second one. Normally, if it works for the first one and the second one, by induction, you could almost get it to work for the third one and the fourth one. Okay. So let's check the fourth one out. Okay. Again, if we plug in n equals to 1, the output has to be equal to 8. So substitute n equals to 1. So do you see how here n becomes 1, n becomes 1. So 1 plus 1 is 3. 3 squared becomes 9. 1 squared is just 1. So S of 1 equals to 8. So D does work. But we will check it one more time. Here's the original function. For n equals to 2, the output has to be equal to 12. Once you plug it in, n equals to 2. So 2 plus 2 is 4. 4 squared becomes 16. It's 16 minus 4. 16 minus 4 does get you 12. So we would say D does work. It worked the output for the first term when n equals to 1 and for the second term of n equals to 2. So we would say D would be the correct answer. Alright, this is part 5, so I'm going to stop here.